So what we did next was we started taking the roots and writing the factors. So here we have a polynomial with some roots, 5, root 7, and 0. And then we also learned here that if root 7 is a root, then we also have negative root 7. Because irrational roots, they always come in pairs. So if we're finding the factors here, 5 is a root, then x minus 5 is a factor. And if root 7 is a root, plus or minus root 7, then that meant x squared minus 7 was a factor. And if 0 is a root, that meant x was a factor. So this polynomial would be the product of these factors here. And you do not need to multiply those out, even though I know you could. Next, we throw in an imaginary, which makes this a little more difficult, but imaginary roots always come in pairs as well, in conjugate pairs. So if 2 plus 5i is a root, then we have 2 minus 5i is a root. So this is going to have 3 roots. 3, which that's the easy one, x minus 3. And then we have our imaginary roots here. So this is going to be x minus, and then we're going to go 2 plus 5i. And then we also have x minus, and I have to put this in parentheses here, 2 minus 5i. Okay, so if I can go ahead and distribute through this negative and rewrite this a little bit, I'm going to actually have x minus 2 minus 5i if I distribute that negative, and then here I have x minus 2 plus 5i. So what happens here every time is that this is kind of like the difference of squares where your middle two terms always cancel each other out. So if I group these like this and this, when I FOIL this out, and that and this, okay, then this is always going to be the product of your first two terms, which is x minus 2 squared, and your last two terms, which is going to be negative 5i times positive 5i. So we know that that's going to be negative 25i squared. You should never have an I squared in your answer because I squared is just equal to negative 1. So that makes this actually just positive 25. And then the product of my first two terms is going to be x squared minus 4x plus 4. Okay, so when you multiply these two imaginary roots like this, what happens is your outside terms and your inside terms are always going to cancel out, which if I take x minus 2 times 5i and I add that to negative 5i times x minus 2, everything's going to cancel every time. So you really only need to consider the product of your first terms and your last terms, which are here and here. So this is a little bit of a shortcut method. And then your remaining factors are x squared minus 4x, and then plus 4 plus 25 is plus 29. So this is where your imaginary roots come from. So if you did the quadratic formula, you would end up with these imaginary roots. And then we had left, of course, the one real root, which was x minus 3. Okay. The last thing we talked about was end behavior and sketching graphs. And there was 3 main things we talked about with end behavior. Leading coefficient, if it was positive, the end behavior is increasing. So that means at the far right side of your graph, as x approaches infinity, so does y. So that's going to go up like that. If its leading coefficient is negative, As x increases and goes to infinity, then y is going to decrease. If the degree is even, both sides go the same. So think of a parabola. The right side increases as well as the left side. And that's the easiest even degree, right? That's y equals x squared. And if it's odd degree, then the endpoints are going to go in opposite directions. So think of x cubed. One end goes up and the other end goes down. So that would be the easiest example of an odd degree function that illustrates that point. So one end goes up, one end goes down when it's odd, and if it's even, they both go the same. They don't necessarily have to go up, but they go the same. Roots and multiplicities, if a root has an even multiplicity, so let's just say one of the roots was x minus 2 squared or something, then that would mean that at that root 2, it's going to bounce back. And anything that has odd roots passes through. So let's take a look at that, and we have an example here with this is going to be, let's determine the leading coefficient x, and then we have an x, but it's actually an x squared because it's going to have multiplicity 2, so there's two x's there and another x here. So the leading coefficient is going to be the product of all of the leading terms in all these factors, and so that's going to be actually positive 1 x to the fourth. Okay, so my leading coefficient is positive. My degree is fourth, so my degree is even. And then all my roots here are 0, x plus 4 squared is negative 4, and that's going to have a multiplicity of 2. And then my last root is 2. So we'll go ahead and just sketch a rough graph showing the end behavior. So I have negative 4 as my smallest root, so let's just say that's somewhere over here. Also have 0, and then I have 2. My leading coefficient was positive, so that means that the end behavior is positive and increases, so that's going to increase. And if it was an even degree, which it is, then the other side's going to do the same. So this side's also going to be going in the positive direction. Now, at negative 4, that's where I had multiplicity 2, which is this root. So it does not pass through the axis, it bounces back and goes back up. And then the other two are both odd multiplicity, so they pass through. So if it has even multiplicity, which would be 2 or 4, we rarely get higher than that, it bounces back at that root. And if it's any odd multiplicity, that's going to pass through. So this is the chapter 6 summary. That's all I got for you here, I think. Yep, that's it. So good luck with this, and spend some time looking over some of this stuff and put in your time and effort, and that will pay off. If you have any questions, feel free to let me know in class, or you can also leave comments at the bottom here, and I can try to answer those if I go back and take a look at this. So study hard, and we'll see you in class.